Math 20-3. Today we start a new unit, slope and rate of change. If you're getting tired of geometry and shapes, look no further. Kind of. There will still be some triangles. Not really much today. Okay, let's begin lesson 3.1. Introduction to slope. Slope is the ratio of rise being the change in vertical distance, to run, the run being the change in the horizontal distance. Slope tells us both the steepness and the direction of a line. The formula to calculate slope can be seen below, right here. Let's draw just a simple diagram to visualize slope. The diagram will be a triangle with a rise and a run. And the slope here as what we would call the hypotenuse. The variable m is used to denote slope. Slope can be written as a fraction or as a decimal. When the slope is written as a fraction, it should always be reduced to lowest terms. For example, the fraction 6/8 would actually be written as 3/4. A reminder that your calculator will most likely be able to reduce fractions. Okay, back to filling in the blanks. There are no units attached to slope because it is a ratio, not a measurement. Just a reminder that a ratio is when you take a fraction or when you divide two things with the same units. It's a comparison. The rise and the run must be in the same units to calculate slope. Slopes are very important in the real world. In trades, workers must know how to calculate slope to ensure the building codes are being met in the construction of wheelchair ramps, driveways, decks, drainage. You'll also sometimes see slope or gradient involved in road signs for semi-truck drivers and lots of other places. Now complete the two class examples together. Let me read this one first. Alexandra is building a wheelchair ramp that covers a horizontal distance of 1,000 centimeters and a vertical distance of 30 centimeters. Calculate the slope of the wheelchair ramp. The first thing you'll want to do is highlight or underline the keywords and values. Horizontal distance of 1,000 centimeters. I'll use a different color for the vertical distance of 30 centimeters. Also a reminder, horizontal distance is referring to the run, and vertical distance is referring to the rise. So, next step is to write the formula that we see above. M equals rise over run and then we need to substitute the values for rise and run. 30 divided by 1,000 and at this point you could type it into your calculator. You could get a fraction or a reduced fraction or a decimal. The reduced fraction is 3 over 100. Or written as a decimal, 0.03. Now I will read class example 2, and we will do that one together as well. Jim Bob is building a wheelchair ramp that must have a slope of 0.02. If the ramp must cover a vertical distance of 90 centimeters, what horizontal distance must the ramp cover in meters? Again, first, we'll highlight the key words and values. A slope of 0.02 has been given. And we've also been given a vertical distance of 90 centimeters. Here I may underline the question. We're having to calculate the horizontal distance in meters. My next step will be to write down the formula. Slope equals rise over run. And then I need to substitute the numbers or the values into the formula. So I have a slope and I have the vertical distance or the rise. So let's replace those numbers. At this point we need to solve, and the method that we've been using this year is to set up a proportion. Let's make a note. So, in order to set up a proportion, we just need both sides to be fractions. We make the left side a fraction divided by 1. we've gotten quite good at this point. Multiply the values on the diagonal and then divide by the leftover value. So let's do that work over here. X is 90 times 1 divided by 0.02. The value of x that you get should be 4,500 centimeters. 4,500. Now, we aren't quite done because we need to answer in meters. And currently we have centimeters. So, feel free to choose your preferred method using a proportion again. I am going to use unit analysis for this one because I like it for this one. I'll take my 4,500 centimeters and I will multiply by the conversion. There is 100 centimeters for every 1 meter. Therefore, my final answer, 45 meters. To summarize the information from this question, the ramp has a slope of 0.02. It has to cover a horizontal distance of 45 meters, and it will rise a vertical distance of 90 centimeters. This concludes the teaching portion of lesson 3.1. You'll now move on to completing the on my own questions. Remember to check your answers with the answer key at the end of each lesson, and do not hesitate to reach out and ask the guest teacher questions if you need help. Good luck.